Up until now, we've been able to do quite a few things with Karel, but it's about to get a lot more involved. See, I've been kind of lying to you since the beginning. I know we did say that Karel can do 4 things, and I just want you to kind of remind yourself of what those 4 things are. We talked about the 4 commands. Karel can move, Karel can turn left, Karel can pick up a beeper, and Karel can put down a beeper. But Karel's actually a lot more complex than just these 4 commands. In fact, Karel can do so many more things. What you didn't know is that every Karel model comes equipped with actually an array of different sensors, which means that Karel can see things in the environment around them. Now, let's actually take a look at what these different sensors can actually pick up on. So I'm going to move over to a sheet that's also linked down below that talks a lot about the things that Karel can do. And we're just going to walk through this together. This video is not actually going to involve you writing any code. You can just follow along and kind of listen. And if you're really an avid note taker, you're welcome to take notes. You definitely don't have to. So this is what we're going to call our Karel one-pager. Now, it's going to be super useful going forward to have this open as we are doing different things with Karel, because sometimes it's hard to remember all of these different things that now you've figured out Karel can do. Up here, we have our standard Karel methods, right? These are the 4 we know and love. Karel can move, turn left, put down a beeper, and pick up a beeper. But now what we found out is that Karel, like I said, can actually sense information about the world around them. So what kind of things can Karel tell? Karel knows if their front is clear. Now, what does that mean? I've just made this little example that I'm going to run just so we can have a Karel world kind of up and going. Right now, Karel's front is this kind of long part here. Karel's front being clear would be true. That would mean that Karel has nothing kind of directly in front of them. Now note that these kind of different clear sensory conditions, those only apply to walls, not to beepers. So this would still be true if there was a beeper here, but not if there was a wall kind of right in front of Karel. There's also gets a little more self-explanatory based on the next ones. There's left is clear. Weirdly, Karel's left is kind of like the top of their head. So we're really checking is there a wall right here? We've got right is clear, which is a similar thing. Karel's right is actually their feet. In this case, Karel's right is not clear because there is a wall actually to the right of them. We have, is Karel facing north, south, east, or west? Again, these are fairly self-explanatory, right? Currently, Karel is facing east. If Karel actually turned left 90 degrees, Karel would be facing north. And if Karel turned right 90 degrees, Karel would be facing south. So it's always the direction that this kind of front part is looking towards. We also have, these 2 are pretty useful, are there beepers present? This means that right on the spot Karel is standing, is there a beeper there? This one will be useful. Sometimes we want to use beepers to kind of find a location, or we're trying to find where the next beeper is or something like that. That condition will be useful then. And I talked about this, I think, in an earlier video, but Karel carries a kind of Santa bag full of beepers. Sometimes that bag starts with 0 beepers in it. Sometimes it starts with 1 or more beepers in it, all the way up to infinity beepers, right? Karel's just Santa throwing beepers all over the place. This will tell us yes or no, or true or false, are there beepers in Karel's bag? And that can be useful as well. We have all of these kind of positive conditions on the left side here. Each one also has the negative condition. Is Karel's front clear, or is Karel's front currently blocked? Is their left blocked, right blocked, etc. And you can see that there is kind of the opposite condition for each one of these possibilities. Now you might be wondering, how do we actually use these? Each of these sensory conditions is like a little question that we can ask ourselves. Is Karel's front clear? Is Karel not facing to the south? But the question is, how do we actually get that idea of is in there? How do we ask the question using the sensory condition? Well, we can actually use what we're going to call our Java control structures. When we combine the sensory conditions with our control structures, we can actually create more complex code. We're able to check these conditions or check the things around Karel. Now, there's 4 different control structures we're going to talk about. The first on the top left here is called the if statement. And how this works is I can do if some sensory condition is true, then maybe Karel can do something. Let me show you an example of this. Right now I have this kind of wall world open. Let's actually open it up and write a little bit of code in here. I could write something like, if front is clear, we're going to move. Now, what does this actually mean? When will Karel move here? Only when or if their front is clear. Now, the important part about an if statement is that it's a statement, which means it happens once. So what's going to be happening here is we're going to assess one time, is Karel's front clear? The answer is yes. So what should happen when I run this code is that Karel moves one spot. Let's see if that's actually the case. I'm going to go ahead and run this. And when I click Start Program, Karel will indeed just move one spot. We've done that single if statement. The condition was true. Karel's front was clear, so they moved once. There's a very similar one called the if-else statement. The way that this works is if you want to give an option in case your sensory condition is not true. Like maybe you want to say, if Karel's front is clear, I want to move. But if it's not clear, that's where the else comes in. Let's say maybe I want to turn left. Now, we know in this case, in this world, Karel's front was clear. So this should still do the same thing that our original if statement did, which is move. But let's actually reset the program, and you can actually do this thing where you edit a Karel world. So let me actually just add in a wall directly in front of Karel, which is kind of a bit of a mean thing to do. Now Karel's front is not clear. So what should happen? I won't go into the first part of this if statement. The else should happen, which means Karel should turn left. So when I start the program, look there, Karel's front wasn't clear, and now they turned left to kind of avoid the wall. So you'll use this if-else statement if you want to give a secondary action to do in case the condition is not true. Remember, both of these on the top are statements, which means they are happening a single time in your code. That's a little bit different than these two on the bottom. This first one that we're going to talk about is the while loop. The way that a while loop works is it's similar to an if statement, except it gets checked over and over and over again. So let's see kind of how this plays out in practice. Let me change this a little bit. Instead of if front is clear, let's change this to while front is clear. I'm going to move, which means that what am I going to do once this program runs? Well, Karel's right here right now. Is Karel's front clear? Yes. So Karel's going to move one spot. Then, since it's a loop, I'm going to keep going. Is Karel's front clear? Yes. Is Karel's front clear? Yes. And I'm going to keep doing this until this condition is actually no longer true. For this condition to not be true anymore, that means there would have to be a wall directly in front of Karel, which is true at spot 7. So what this code should do is Karel should move all the way forward until they hit spot 7 and then stop, which is actually what happens. So you can see that in a while loop, I'm checking that condition over and over and over again. I'm doing the thing that's inside of my while loop while this is true. And once it's not true, then my while loop will be finished. I'm kind of down here outside of these curly braces. Now, we also have another way that we can repeat code it over and over again, which is called a for loop. We use a for loop when we want to repeat code a certain number of times. The syntax for a for loop is a little bit yucky. There's kind of all this stuff going on. All you need to know right now is that whatever number you put here, that is exactly how many times the for loop will repeat. So let's do this. Let's do for, and this is just the way you type it, int I equals 0. I is less than, let's do 5. I plus plus, and let's do move. So what's going to happen here when I run this? Karel should move exactly 5 times. There we go. Karel did 5 moves, went from spot 1 to spot 6. Now, there's one important thing to note about the for loop, which is that I didn't actually include any sensory conditions here, which means that Karel's not checking right now that the front of them is actually clear. Let's say I changed this 5 to be like a 9 instead. Remember that there's a wall between 7 and 8, so what's actually going to happen when I run this? Let's try it out. Oh no, we accidentally killed Karel. And that's because, again, a for loop is not going to check any sort of sensory condition. Whatever you code you put in here is going to happen exactly this number of times, whether or not that should be happening. When do you use a for loop versus a while loop? You'll use a for loop when you know exactly how many times you want a piece of code to happen. And you'll use a while loop when you don't necessarily know how many times, but maybe you know some sort of ending condition. I want to move while this is true, or I want to turn left while this is true, or something like that. You're able to check something about the world around you and move based, or do some action based on that. So we're going to use these control structures constantly throughout our next bunch of Karel programs that we're going to write together. These are going to be super important. And like I said, it's going to be really great to have all of these out in front of you. Probably the most challenging part of what we're going to do going forward is that you're really going to need to kind of hone in that ability to know when you're going to use a while loop versus a for loop, and we kind of talked about that distinction a little bit earlier, as well as when you're going to use a statement, something you only want to check once, like an if statement, versus a while loop. Do you want to check it once, or do you want to check it over and over again? These are some problem-solving skills that you'll really get to hone in as we keep writing these Karel programs together. Next time, we're actually going to write a pretty cool program that will send Karel to the Olympics in their Olympic winning event. And we're going to use these control structures and these sensory conditions to make it so that Karel can run any different type of Olympic race in their particular event.